Today's lesson is the entire chapter 12. It is on surface area. You're probably familiar with this from grade school, so I'll try to move through this quickly. Surface area is simply the amount of area that it takes to cover an entire object. This is not to be confused with volume. Essentially, it's the area of all the faces or surfaces of a solid object. Okay, we begin with prisms. It's just a quick word on prisms. In elementary language, I guess we would call these boxes. The important thing about every prism is that it has bases. That is a top and a bottom. In many prisms, there are polygons other than rectangles. So this would be a hexagonal prism, for example. You can have a triangular prism or an octagonal prism. You can even have rectangular prisms. They're a bit of a special case. You can see the other information here. The most important thing here is that this is a base and that this is a base. The height of the object is also important. It's measured from the top to the bottom. Okay. Here we have what you'll see most often, a right prism. If a prism is leaning over, it has, it's called oblique. Okay, we speak of the lateral area of a prism. We're talking about the sides. Lateral means sides. And so I've cut apart this hexagonal prism. The lateral area is going to be the area of the sides. It's not difficult to see that this is the height of the prism. And this side right here, well, it's the 6 sides of the hexagon. It's the perimeter of the base. So the lateral area is just perimeter times height. Quite simple. So if I want to find the lateral area of this prism, I simply use the formula lateral area equals perimeter times height. The perimeter of the base is 6 times 5, which is 30. The height, even though it's on its side, the height is the distance between the bases. So that's going to be 12 centimeters. 30 times 12 is 360 square centimeters. Again, anytime we measure area, whether it's surface area or just normal area, it's always measured in square units. Okay, if I want to figure out the entire surface area, I've already counted up the lateral area. Now I've got to count the area of this base and the area of that base. Well, there's 2 of them, and because the bases might change, it might be a triangle or a hexagon or what have you, we're just going to put a capital B for the area of the base. This is not to be confused with a lowercase b, which is a linear measurement. Capital B is a square measurement. It's already an area. So let's look. I've got a square prism here. I'm going to immediately recognize that this square and this square are the bases. We need to find the total surface area. That's why we use T. Total surface area is perimeter times height plus 2 times the base. Well, the perimeter is that of the base. The base is a square. Its perimeter is going to be 4 times 6, which is 24 for the perimeter. The height is the distance between the squares, which is 12, plus 2 times B. B is the area of the base. It is not a linear measurement. It's an area. Well, the base is a square. The area of the square is going to be 6 times 6, which is 36. So here we have 288 plus 72. It's also 360, interestingly enough. Okay, surface areas of cylinders. Cylinders are a lot like prisms. The only difference is the base. The base is not a polygon. Instead, the base is a circle. Again, if it's standing up straight, it's a right cylinder. Otherwise, it's oblique. Okay, for a cylinder, the lateral area is again the area of the sides, or it's just a really long rectangle. This dimension, like with the prism, is the height. And this dimension, in a prism, it's the perimeter. But in this situation, our base is a circle, and so we don't call that the perimeter, we call that the circumference. We haven't done chapter 10 yet, but the circumference of a circle is simply 2 pi r. So, to find the lateral area of a cylinder, it's the base times the height. Okay. If we want to include if we want the entire surface area, the T, the total surface area, I've already got 2 pi r h. Now I have to add the 2 bases. So just like last time, it's 2 times the area of the base. However, for every cylinder, the base is always a circle, and the area of a circle is pi r squared. So it's quite a simple formula. Okay, find the surface area of the cylinder. I'm going to write down my formula. 2 pi r h plus 2 pi r squared, and plug stuff in. 2 pi, the radius is 14, the height is 18, plus 2 pi, and the radius again is 14. I invite you to plug that in your calculator. I have no intentions of doing it in my head. Find the radius of the base of a cylinder if the surface area is 128 pi and the height is 12. Okay, so in this situation, we're using the same formula. The only difference is they've given us the total surface area and we have to solve for the radius. So I'm plugging everything in. 128 times pi is the surface area, 2 pi. The radius is, we don't know the radius. The height is 12 plus 2 pi, don't know the radius, squared. You'll notice that every term has pi, so I'm going to divide both sides by pi. Should make it a little bit better. I'm going to divide this by pi, but I still got a 2 and a 12. That's 24r. Divide by pi, I'm left with 2r squared. Again, I'm going to divide by 2, just to simplify things. Okay. What I have here is a quadratic equation. I need to subtract 64 from both sides. And I'll need to factor this. This one's fairly difficult. We won't do a lot like this, especially since we're in such a hurry. Okay, at this point, I know that one of these two factors is equal to 0. Either r is negative 16 or r is positive 4. We're talking about the radius of a cylinder. It certainly can't have a negative radius, so the answer is 4. Okay, moving right along. Surface area of pyramids. Okay, a pyramid is simply a polygon as a base, and then all the sides are triangles. Unlike a prism, which has a top and a bottom, a pyramid only has one base. There are two important distinctions to make here. One is that of the height of the pyramid, and the other is the height of each of the triangles that make up the sides, the lateral faces. This is called slant height here, or slant length. It's sometimes referred to as slant height. For the purposes of surface area, we only need to know the slant length. We do not need to know the height. I do want to point out, however, that every pyramid, every right pyramid, you have a right triangle around the height, the slant height, and 1/2 of the side length. So that's an important thing to notice. Frequently you'll have to use, they'll give you the slant height or the height, and you'll have to find the other using the Pythagorean theorem. Okay, I'm just going to give this to you. The total surface area of the pyramid is 1/2 perimeter of the base times the slant height plus capital B, which is the area of the base. It's not just a linear measurement. Again, it's a capital B, so it's the area of the base. We'll work an example. Find the surface area of the regular pyramid. I'm going to use the formula 1/2 perimeter slant height plus the area of the base. Okay, 1/2. Let's look at the perimeter. Well, in this situation, I need to identify the base. Here's our base. It's a triangular pyramid, and they told us that it's regular. Therefore, I know that all three sides are 8, so the perimeter is 24. The slant height, okay, this one in the middle represents the height of the triangle, so they're actually giving us the slant height here. It's 10 plus B. B is the area of the base, which is going to be a little bit difficult. It's a regular pyramid, so it's a regular base, so it's an equilateral triangle. All the sides are 8. I'm going to split it in half. If it's equilateral, all the angles are 60 degrees. We have a 30, 60, 90 triangle here. The hypotenuse is 8. This half is 4, because the short leg is half of the long leg, or the half of the hypotenuse, and the long leg is 4 square root 3. So, using our formula for the area of a triangle, it's going to be 1/2 base. This is a little b. The base of this triangle is 8 times the height, which is 4 square root 3. And again, plug this directly into the calculator. I'm not going to do that. I can't do the square root of 3 and all that in my head. All right, surface area of cones. This, I hope you'll notice, is Oh, actually what I have up here is the surface area of a pyramid. And a cone looks a lot like a pyramid. The only difference is that its base is a circle. Therefore, we're going to have to change a little bit about this. 1/2. Well, the perimeter of our base, the perimeter, this is a circle, so its perimeter is the circumference, which is 2 pi r. And slant height is the same, plus b. B stands for the area of the base. Well, if the base is a circle, its area is pi r squared. And you'll notice that 1/2 of 2 is just 1, and therefore, this is our formula. The total surface area is pi rl plus pi r squared. The brilliant thing here is if you memorize the surface area of a pyramid, you've memorized the surface area of a cone. All right, this is a more complicated example. I could choose a very simple one, but I thought I'd choose a more complicated one. Real quick, before we start there, I just want to point out, again, as with pyramids, the radius of the circle, the radius of the base, the height, and the slant height form a right triangle. So you'll be using Pythagorean theorem a lot to solve these problems. And again, the height of the cone does not matter, only the radius and the slant height for finding surface area. Okay, so what I have here, I hope you can picture this, is a solid cylinder, and someone has bored out a cone. So to find the surface area of this, we need to count up all of the different parts. Okay, the cone here, we'll count that first. Let's count the surface area of the cone. Only thing I want to point out is it's missing the bottom. So when I find the surface area of the cone, it's going to be total surface area, and I'm going to draw a cone. Total surface area of the cone is pi rl plus pi r squared. Now, as you remember, pi rl is the lateral area, pi r squared is the base. Well, in this case, the cone, the part that we would have to paint, doesn't have a bottom. So we're going to actually erase the pi r squared. Okay, we can go and figure that out. Pi, the radius is 6.2, and the slant height. Oh, well, we're going to have to use Pythagorean theorem to find that. 6.2 squared plus 14 squared equals my slant height squared. Let's get out the calculator. 6.2 squared plus 14 squared equals that. I want to know what the square root of that is. Oops. Second, square root of the answer. It's about 15.31. So L is 15.31 approximately. All right. So plug this in. We'll have the surface area of the cylinder. Of the cone rather. And now we have to find the surface area of the cylinder. The surface area of a cylinder is equal to 2 pi r h plus 2 pi r squared. Again, 2 pi r h is the lateral area. That's this part right here. One of the pi r squareds is here. The other pi r squared is here. Oh, but we're missing that. We don't have to paint that. We don't have to cover that. So I'm going to erase one of these. Oh, we just want 1 pi r squared. And we'll plug it in. 2 times pi. The radius is 6.2. The height is 28 plus pi, and the radius is again 6.2 squared. So, to save time, I'm not going to plug all this into the calculator, but you're going to plug in that part. We'll tell you the green part. I can actually highlight it. That's the inside of this part right here. And what we have in pink is the outside and this end. Okay, the surface area of a sphere, this one's very simple. The surface area of a circle, or the area of a circle is pi r squared. The surface area of a sphere is 4 times that. The only thing I want to point out here before we move on is that ring there, the largest circle in a sphere is called the great circle. And if we were to crack a sphere in half, the area of the hemisphere is actually 3 pi r squared. The outside part is 2 pi r squared because it's half of the whole sphere. And then we also have to count the part that's open, and that's 1 pi r squared, so a total of 3 pi r squared. We're just going to work some examples like here. Surface area of a sphere with a radius of 25 inches. It's quite simple, it's very straightforward. Total surface area is 4 pi r squared. Plug it in, you're done. Find the surface area of a sphere given a great circle with an area of 907.9 square centimeters. Okay, well, here's our sphere. The great circle, if it has an area of 907.9, and we know that the area of a circle is pi r squared, we can find the radius of this great circle by dividing by pi and then taking the square root. So the radius is 907.9. I divide by pi and then take the square root. You will approximate that in your calculator, and then you'll just plug it into the formula 4 pi r squared. Okay, hemisphere. Find the surface area. Oh, it tells us the radius. The total surface area is 3 pi r squared. Again, just plug it out into the calculator. If they tell us the circumference of the great circle, what's a hemisphere? The circumference is equal to 40.8. The circumference of a circle is 2 pi r. So to find the radius, I simply divide 40.8 by 2, and then I divide it by pi. That tells me the radius. Once you approximate the radius, plug that into the formula,